Hi everyone, welcome back to our channel. In the last video, we learned about the provider block, the resources block, and even we have created a small demo VPC using Terraform. In today's video, we are going to talk about something that makes Terraform super powerful and reusable Terraform modules. When you start learning Terraform or implementing things, if you have ever felt confused where to start and how to write Terraform scripts, or tired of copy pasting the same code again and again, this video is going to save you a lot of time and make your life much easier. Stick around till the end because I will show you a real world example that you can start using right away. Let's first understand modules with a simple example. Imagine you are walking into a big shopping mall. Everything inside this mall is organized in a proper way and everything has its own place. Now think of this entire mall as your Terraform project. The mall itself is the main project, but inside it has many sections like menswear, womenswear, electronic products, gift items, and their respective billing counter, trail rooms, etc. All are kept in their own sections, nothing is mixed up. Terraform modules works the same way. They keep your code neat and organized in sections. For example, the men's section is one module. Inside it, you have smaller sections for shirts and pants and etc. These are like submodules. They are built once but can be reused whenever it is needed. On the other side, you will see women's section, same idea, organized sections inside one bigger module. This structure makes everything easy, reusable and predictable. Now let's continue with our shopping mall example. Before you buy anything, you first go to the trial room and try on the clothes. You just check how they look and fit. Nothing is finalized yet. That's exactly what Terraform plan does. It gives you a preview of what Terraform is about to do without actually making any changes. Once you are happy with what you see, you head into billing counter. That's like running Terraform apply. This is the step where everything becomes real. Your infrastructure gets created just like you walk out of the mall with your shopping bags. And if one day you decided you don't want something anymore, you go back to the replacement desk. In Terraform, that's Terraform destroy, which removes the resources you no longer needed. Now let's connect this example to real Terraform modules. Terraform has a registry which is like an online store or catalog for discovering and using pre-built modules. Here you will find modules published by providers like AWS, Azure, Google, HashiCorp, etc. For example, if we search for VPC in the Terraform registry, we will find multiple modules. You can also find the official AWS VPC module. It will show us the source code, the version, and even the number of downloads weekly, monthly, and overall. If you click on the source code, it will redirect to GitHub page where all the source code of VPC module is available. Inside this VPC module, you will also notice that it contains submodules. For example, you may find a folder called modules, and inside it, more specific submodules are available. This is just like our shopping mall example, a men's section with shirts, pants, and other sections inside it. Now, every mall works with proper planning and records. A Terraform project also has a few important files like main.tf, variable.tf, terraform.tfvars, output.tf. Let's understand each file. Main.tf. This is the blueprint of the mall. It defines where the men's section is, where the women's section is, and where the billing counter is, and so on. It decides which module to use and how they connect together. And variable.tf. This is like your shopping options like shirt sizes, colors, and whatever you want. In Terraform, variables let you choose different options like region, machine size, name of the resources, etc. Terraform.tfvars. This is your actual shopping list. You pick your size, color, and quantity. In Terraform, this is where you set real values like region is ap-south-1, instance type is t2.micro, etc. Outputs.tf. This is your receipt. It tells what exactly you bought. In Terraform, outputs gives you details like server IP, subnet IP, and other URLs, etc. And here are some key points for choosing the right module. Since modules are open source, not all are high quality. Here, how you can decide? You can find the verified badge, means it's from HashiCorp or an official partner. You can also check the downloads. For example, in the VPC module, you can find downloads. It has number of downloads, yearly, overall, and weekly. And you can also check the update frequency. That is nothing but the recent commits. It means it is actively maintained. You can also check the README files. So it provides the multiple informations like inputs, outputs, resources which are supported. So let's quickly recap of our example. The mall which is we assumed as a Terraform project, and the sections like men's section, women's section, which is nothing but as a modules. And inside the modules there are multiple files like main.tf as our mall's blueprint, variable.tf as our shopping options, terraform.tfvars as our shopping list, and finally outputs.tf is our final receipt. Before jumping into the demo, let's recall our previous video where we have created a VPC manually. While creating the VPC manually, we have provided some inputs like region, VPC name, VPC seeder block. And also while creating the public and private subnets, we have also provided details such as availability zones, subnet ranges. Along with that, we also created NAT gateway and we have did some few settings for public subnet. The same information we are going to use as inputs to Terraform. By using these inputs, Terraform will create everything for us. Alright, let's do a quick demo and create all of this using Terraform modules. I will open Visual Studio Code and start with our first main.tf file. Here we are going to create a VPC using a module from Terraform registry. We begin with a module block. Here you don't worry about memorizing the syntax, just go to the official Terraform registry. Look at the provision instruction section and copy it to your main.tf file. Well, we have named our module as VPC. Inside the source is set to terraform-aws-modules/vpc/aws. That simply means we are pulling the official AWS VPC module from Terraform registry. Next, we fixed the version to 6.0.1. You can always check the Terraform registry for other versions, but as per best practice, try to stick with the latest stable release. And inside this module, we have given the VPC name as vpc-dev and seeder block is 10.0.0.0/16. We will use two availability zones as US-East-1A and US-East-1B. Inside this VPC, we will create two private subnets with ranges of 1.0/24, 2.0/24, and two public subnets with ranges 3.0/24 and 4.0/24. Now don't worry if you are wondering how do we actually provide all these details to Terraform. It's very simple. When you go to the official Terraform registry page of this module, you will find a section called Input. This is like your reference guide. For example, if I want to define CRDR in my Terraform file, I just fetch for CRDR in the input section. It clearly tells me that the syntax is a string. So I have provided this range in string. Similarly, in the above, you can find availability zones. It mentions list inside string. That means I can provide multiple values inside square brackets like multiple availability zones 1A, 1B, 1C, etc. So basically you don't have to memorize anything, just check the input section, see the type of value expected and then give your details accordingly, like for VPC name, CIDR, public subnet, private subnet and so on. For outbound communication, we enabled a NAT gateway and configured it as single NAT gateway. Next, we configure DNS parameters. This makes sure our resources inside the VPC can use DNS properly. We also add tags to identify our subnets. Finally, we apply some general tags like owner, environment, and we also add a VPC tag with the name VPC-dev. Now finally, we have written our Terraform code. Let's walk through the standard workflow we always follow when working with Terraform. Step 1. Terraform init. This is very first command we run. It initializes our work directory, downloads the necessary providers, and if you are using any modules, it will pull them from the Terraform registry or GitHub. Think of this as preparing your toolbox before starting work. In step 2, Terraform plan. Next we run Terraform plan. This is like a dry run or a preview. Terraform shows us exactly what it's going to create, update or delete without making any changes. It's like looking at the trial room mirror in our shopping mall example. It's get to see what's going to happen before you commit. And step 3. Terraform apply. Once you are happy with the Terraform plan, we run Terraform apply. This is the execution step. Terraform provisions the infrastructure on AWS or any provider you are using. For example, if you have defined a VPC, subnets and NAT gateway, apply will actually create those in the AWS console. It's like going to billing counter, paying for our items and walking out of the mall with our shopping bags. After apply finishes, it's always a good practice to log into the AWS console and double check. You will see the VPC, subnets and other resources created exactly as defined in our Terraform code. This builds confidence that everything is working as expected. Hence, this is a demo. We are going to delete all the resources. Like this is like final the step, Terraform destroy. Finally, once you are done testing or if we don't need the resources anymore, we run Terraform destroy. This command clean up everything that Terraform's created. It's very important because leaving resources running in AWS can lead to unnecessary charges. Destroy makes sure we don't spend money on resources we don't actually need. Now let's imagine a real world scenario. Today we created this VPC for our development environment. But what if tomorrow I want to set up same thing for production? The best part about Terraform modules is I don't need to write everything from scratch. I will simply reuse the same VPC module and only changes a few inputs. For example, instead of calling it VPC-dev, I will rename it to VPC-prod. I will update the CRD range so production has its own dedicated network space. For example, 10.1 instead of 10.0. Then I will adjust the subnet ranges for both public and private subnets so they don't overlap with development. If my production is going to run in the same region like US-East-1, I will keep the region as it is. But if the business requires another region for compliance or high availability, I can just change it here. But in this example, I'm not going to change the region. And that's it. The rest of the configuration stays the same. NAT gateway, DNS settings, All of those are already built into the module. Now when I run Terraform plan and Terraform apply, Terraform will provision a brand new production ready VPC with just those few changes. This is the real power of modules. Once you have designed everything, you can reuse it for multiple environments like dev, testing, staging, and production by simply changing inputs. The Terraform apply execution has completed. Let's quickly check the resources that are newly created. Let's go to our VPC. Here we will first check the VPC name and the VPC CADR. Oh sorry, here we made a small mistake. Everything we have modified but forgot to modify the tags. Let's go to our Visual Studio and quickly change the tags from dev to prod and reapply the changes. This is the real beauty of Terraform. Once everything is ready, you can quickly apply the changes. The execution has completed. Let's go to console and re-verify the resources with new tags. And that's it for this video. We have understand the basic concept of Terraform modules, the important files that makes up a Terraform project, and we even tested a demo by hard coding the values directly into our configuration. In the next video, we will take this as a step further. Instead of hard coding values, we will implement variables, tfvars, and output files, which will make our Terraform code more flexible, reusable, and production ready. So make sure to stick around for that. If you found this helpful, don't forget to like, share, and subscribe to support the channel. Thanks for watching, and I will see you in the next video.